All right, we're going to talk about simplifying radicals now. And remember, a radical is just this symbol right here, right? If that radical has a 2 there or implied 2, it's a square root. This says the square root of 16. This says the square root of 12. Well, since 16 is a perfect square, we know that that is just 4. But what about the square root of 12? 12 is not a perfect square, so there isn't a specific number times itself that gives you exactly 12. So what we have to do if we want to simplify this radical, this one is considered simplified. It's done. Can't be any simpler than that. When we simplify radicals, we still may end up with a radical, but we don't want the number to be something that can still be simplified. So when I look at this, I see the 12. I'm going to rewrite the 12 using a factor tree. I want to write it in prime factors. So we use prime factorization or that prime factor tree. Any two factors of 12, say 4 times 3. Well, 4 can be broken down into 2 times 2, and this 3 can be brought down. So I can rewrite 12 as 2 times 2 times 3. Now remember, the square root has a 2 here. In order for me to pull something out of a square root, I'd have to find pairs. And since I do actually have a pair of 2's, that pair of 2 comes out as a 2. Now what else do I still have? Well, I still have the square root of 3. That's still left in here. And this is considered simplified. This is that simplified. Okay, that's what we're talking about by simplifying radicals. I cannot pull anything else out of the radical because 3 is prime. There's nothing else I can pull out. Let's do another example. This time I'm going to involve some variables. So for example, what if I asked you for the square root of x to the third, y to the second? Same idea, right? I can rewrite these things. I can rewrite this as the square root of prime factors of x to the third is just x times x times x. The prime factors of y to the second is just y times y. In order for me to simplify this, I need to be able to pull pairs out. So there's a pair, there's a pair. This will give me an x on the outside. This will give me a y on the outside. But I still have some stuff left on the inside. Still have my radical, and I have this one x right here. So if I were to write this out simplified, it would be xy times the square root of x. All right, let me try another example here. What about 16, the square root of 16 x to the third? Well, I can rewrite 16 in prime factors. Now I can break it all the way down, but I know it's 4 times 4. And then I can write the x's, x times x times x. Since it's the square root, I'm looking for pairs. So there's a pair, there's a pair. Every time I have a pair, I can pull out one of those items. It represents a 4 on the outside and an x on the inside. I'm sorry, an x on the outside. And I still have this x on the inside. I guess I don't need it to be that long. So this would be simplified. And then let me try one that's a little bit longer, like 32 x squared, no, let's say x cubed, y squared, and then w to the fourth. Still the same idea. Let's write this thing in prime factors. Well, I don't know 32 off the top of my head, so let me break that down. That's 8 times 4. That gives me 4 times 2. That gives me 2 times 2. That gives me 2 times 2, and then bring down these 3. Oops. And so I can rewrite this as, I'll do it down here, 2 times 2 times 2 times 2 times 2, that's 32. And then x, 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 that's x cubed, y, y, and then w, 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 w. So all I did was rewrite that with all those prime factors. All right, now I'm going to do this kind of quickly. My time is waning. 1, 2, 3, 4, 5, 6 pairs. So it's 2 times 2 times x times y times w times w. That's all of those things. And I still have in there a 2 and an x. Let me simplify this. This is 4x y w squared, square root of 2x.